On those cold, rainy days when you forget your rain jacket or umbrella and you want to stay as dry as possible, should you walk and spend more time in the rain? Or should you run, which means you'll be hitting more raindrops from the side? Assuming you haven't been fully soaked yet and you aren't jumping into puddles, the answer is simple. As you move out of the way of one falling raindrop, you move into the way of another, so the amount of rain hitting the top of you is constant, regardless of how fast you're going. To see this, you can picture that the raindrops themselves are stationary and you and the earth beneath you are moving upwards through the rain. And since the volume of a parallelepiped, that's a 3D parallelogram, doesn't depend at all on its slant, then no matter how fast you're moving horizontally, the same amount of rain will land on top of you each second. Now, if you're not moving, the rain from the top is all you'll get. But if you are moving, you'll also run into raindrops from the side, and you'll get wetter. So in any given second, you stay driest by standing still, and the faster you move, the wetter you become. But if you're trying to get from point A to point B, then standing still won't do you much good. And en route from point A to point B, the total amount of rain you run into from the side has nothing to do with how fast you're going. Just like how a snowplow will plow the same amount of snow from a stretch of road regardless of the exact speed it drives. In the case of running through the rain, you can figure that out using parallelepipeds again. So, over a given period of time, the same amount of rain will hit you from the top, regardless of how fast you're going. And over a given distance, you'll hit the same amount of rain from the side, again, regardless of how fast you're going. So your total wetness is equal to the wetness per second for rain from the top, times the amount of time you spend in the rain, plus the wetness per meter for rain from the side, times the number of meters you travel. So to stay driest, getting from one point to another, you should try to minimize the amount of water falling onto you from above. And quite simply, that means getting out of the rain as fast as possible. Why is the sky dark at night? You might think the answer is obvious. The sun isn't up. But the only reason the sky looks blue during the day is that sunlight scatters off of the atmosphere. If we didn't have an atmosphere, like on the moon, the sky would always be dark, even when the sun is shining. So let's rephrase the question. Why is space dark? I mean, space is full of stars, countless stars which are all about as bright as the sun. And in an infinite eternal universe, no matter what direction you picked, if you looked far enough in that direction, you would see a star or galaxy. So the whole sky should be as bright as the sun, night and day. And since it's not, does the darkness of the night sky mean that there's some distance away from us when stars and galaxies just stop? A boundary between something and nothing? An edge to the universe? Not exactly. All of our evidence seems to indicate that space has no edge, but the universe itself does. Not a spatial edge, but a temporal one. As far as we know, the universe had a beginning, or at least a time about 13.7 billion years ago when the universe was so small and crumpled up with itself that our standard notion of space and time breaks down. And since only a finite amount of time has passed since this so-called beginning, that means that some of the stars necessary to fill up the brightness in every direction are so far away that light from them plain hasn't had time to reach us yet. It's as if the universe were a big thunderstorm, and we're still waiting to hear the thunder from the really distant stars. But wait, it's better than that. Since light takes time to travel across the universe, when we point our telescopes at something really far away, we're actually seeing that part of the universe as it was when the light was emitted. So when we look at 13.5 billion-year-old light, it's not that we don't see stars just because the light from them hasn't gotten to us yet. We don't see any stars because we're getting a peek at the universe before any stars had formed. A starless universe. Now that sounds to me like a pretty good reason why we look up and see a dark night sky. But it's not. I mean, it is true that we can find points in the sky where there aren't any stars by looking past the earliest stars and thus farther back in time. But even when we point our telescopes past the earliest stars, we still see light. Not starlight, but the light left over from the Big Bang. We detect this cosmic background radiation coming more or less evenly from all directions, forming a background beyond the stars. So I guess the night sky isn't actually dark to begin with. Right, so if our telescopes tell us that the night sky isn't dark, then why does it look dark? Here's a clue to the real answer. When the Hubble telescope photographed the distant stars of the astoundingly beautiful Hubble Extreme Deep Field, it took the picture using an infrared camera. Why? Well, distant stars and galaxies are moving away from us because the universe is expanding. So the same way a record slowing down lowers the pitch of my voice, the Doppler effect causes stars moving away from us to become redder. And the farther away they are, the faster they move away from us and the redder they become, until they become infrared. And then we can't see them anymore, at least not with our human eyes. And that's why the night sky appears dark. In summary, if we lived in an infinite, unchanging universe, the entire sky would be as bright as the sun. But the sky is dark at night, both because the universe had a beginning so there aren't stars in every direction, and more importantly, because the light from super distant stars, and the even more distant cosmic background radiation, gets redshifted away from the visible spectrum by the expansion of the universe. So we just plain can't see it. Finally, we've shed some light on why the night sky is dark, and why it isn't.